January 13th, 2018. How you guys doing? I got a printout here of Hess Harry Hammond from the Princeton.edu website. I'll read a little bit of this out to you. And I got a page here, the root assumption of all geophysics and geology. I'll read a little bit of this out to you. The abstract in this goes, the most basic assumption in all of geophysics and geology is the consensus that the Earth has always been solid and liquid rock. The reality is the Earth was not always solid liquid rocks. It was a giant ball of plasma and gas much earlier in its life, much larger than its current diameter. And I have here, the assumption is the Earth is solid liquid now, so it probably was always solid and liquid. And that is very troublesome because the vast majority of the objects we see in outer space that are large like the Earth or larger are actually plasma and gaseous structures. So basically in the 18th and 19th and 20th centuries, they've always sort of kept the assumption that Earth has always been rocky, even though all the observations point towards Earth having been much hotter, much more energetic, and composed of plasma and gaseous material. And I correct it with the Earth was plasma first and then the gas before it was liquid and solid. I know Baz, remember this this graph I printed out? Check that out. Where it has the stars in the very top and they cool, shrink, and die, and they just forgot half the diagram basically. Cell evolution is planet formation. No, we've come a long way, huh? But I'll go ahead and read this out to you. Some of the reasons why it was assumed the Earth was always solid and liquid material, and why they kept the assumption and how it was accepted in those communities as being an assumption. I have here, I had cut and paste this little statement out in Harry Hammond Hess. Is this him? Petrologic Studies, a volume to honor A.F. Buddington. This is History of Ocean Basins by H.H. Hess at Princeton University in Princeton, New Jersey. So this is the real deal. This is where it all begins. It begins at these ivory towers, and they dictate what everybody should believe, and it comes down the line. But it's really bad to do that sometimes, as we'll see here. November 1962. Abstract. For purposes of discussion, contain simplifying assumptions. For purpose of this discussion, certain simplifying assumptions are made as to the initial conditions of the Earth, on the Earth after its formation. It is postulated that it had little in the way of an atmosphere or oceans, and that the constituents for these were derived by leakage from the interior of the Earth in the course of geologic time. Heating by short-lived radionuclides caused partial melting and a single-cell convection overturned within the Earth, which segregated an iron core, produced the primordial continents, and gave the Earth its bilateral asymmetry. So what we see here is simplifying assumptions are made. And the simplifying assumption that he makes is that he just assumes that the initial conditions of the Earth are that it is rocky. But that's completely missing the point entirely, as people that understand this theory have been learning about. You can't look at something and say, well, it's this way now, so it's always had to be this way. That isn't good science. That's making an assumption into a dogma, and that prevents people from looking outside of themselves, and it prevents them from learning how to seek out where the assumptions are so they can make the needed corrections. Of course, this guy's, he was doing his business long before I was even, a twinkle in my mother's eye. But I'll read this little page out for you. I'll link this stuff to the bottom so you guys can read along with me after I, upload it, of course. In 1960, Hess made a single most important contribution, which is regarded as part of the major advance in geologic science of this century, 20th century. In a widely circulated report to the Office of Naval Research, he advanced the theory, now generally accepted, that the Earth's crust moved laterally from long volcanic active oceanic ridges. Seafloor spreading, as the process was later named, helped establish the concept of continental drift as scientifically respectable and triggered a revolution in the earth sciences. This report was formally published in the History of Ocean Basins, that abstract piece, which for a time was the single most referenced work in solid earth geophysics. And you can get a lot from that statement right there. I'll just go over a few points here. For which at the time was the single most referenced. Single most referenced means they take a piece of work and other scientists reference that work, and it branches off like a giant lightning bolt across all the universities around the world, even smaller universities down to high schools, middle schools, and elementary schools. So you really got to be careful what you talk about if you're supposed to be the experts concerning your field of study. If you're an expert in your field of study and you work at Princeton and you say something, you have to be very careful what you say, because people will take that and they'll run with it. And it'll become something that you cannot control, and it will become something that's vastly different than what you expected it to be. And even worse, if it turns out you were wrong the entire time, it takes literal decades, if not centuries, to correct it. As we see here, 1962 was what? 38 plus 18, it's 56 years ago. That's a long time ago, over half a century. And it's still assumed that, like it says here, most reference work in solid earth geophysics. To understand the history of the earth, you have to understand that the earth was not always solid. Our observations of the evolving stars, which scientists call exoplanets, lead directly to the conclusion that Earth was actually very gaseous. And at a point very, very early in its life, it was plasmatic, meaning it was its own sun itself. And a lot of conclusions from that have to be made, which do not exist yet, which is why I'm designing this theory as well. I remember Adam Lohr had said something about how you can match up certain events in our geologic past with the Earth orbiting. The extinctions, the ice ages. Another thing in particular that stuck out to me is I remember I looked it up concerning ice ages, really long periods of time where Earth was apparently a snowball. And one of them in particular, one of the long ice ages that lasted for 60 million years. I thought to myself, well, why would the Earth be a snowball for 60 million years? And it really sort of just makes sense if you put it into context. The Earth didn't always orbit the sun. The Earth has been around vastly longer than the sun has. And the Earth should have gone through multiple ice ages throughout its life when it was being ejected and readopted by other systems. And that, of course, is yet to be considered by the mainstream, because the mainstream always has Earth as being in its spot and has always been in its particular orbit. And that also is itself a major assumption. So two major assumptions here. The Earth was always solid and liquid material when the observations point against that. And two, the Earth has tens of millions of years long ice ages, which, why would something like that happen? Well, clearly if Earth wasn't in its orbit and the sun couldn't heat it, what would happen to the water? The whole thing would freeze over. And it would stay like that for tens of millions of years until it was adopted by another hotter host star. Which means the dinosaurs, the sun wasn't their star. It was a completely different star in the past. Of course, that isn't just the dinosaurs, that's many stages of the Earth's evolution. For all we know, the star that Earth orbited in the past might be in our system, it might be another brown dwarf somewhere else, it might be advanced itself all the way to ocean world stages itself. So I don't know if anybody could figure out the math on that, but we need a much different way of looking at the stars that hasn't, been really thought up yet. That's why I'm doing this. Anyways, you guys, I don't want to make this talk too long, but just keep that in mind. Like, when you look at geological assumptions, realize that all those assumptions are made under the umbrella of the Earth having always been its current diameter, its current mass, its current atmospheric thickness, its current amount of water. It's almost everything is the same, and that's from uniformitarianism, which was the present is key to the past. But sometimes you have to look outside of the Earth for the present being key to the past, as in the actual stars in the sky. All right, you guys, later.